Okay, so good afternoon. My name is Amara Santiesteban Serrano, and I'm going to present the first results of my PhD, which treat about vulnerability of soil functions to a severe wildfire. I know it's a little late, we're tired, so I'm gonna try to be brief and as fun as possible, I guess. As we already know, or maybe learned today, wildfires are increasing in frequency and severity, mainly due to climate change and land uses changes. So that's the reason behind the increase in post-fire scenarios. The effects on the above ground, they are most times obvious because we can visually assess them. But what happens to soil, it remains tangled up still. So as we learned before, soils play a key role in nutrient and water cycling. They hold life on Earth, and it also provides a lot of ecosystem services. So that's why one of the main questions of our study was to determine if soil function indicators were affected by fire severity, or is just a matter of burn versus unburn. The second question we had, it was if fire affected the vertical distribution of soil function indicators. This being, for example, if is fire only affecting the topsoil, or it may go little down deeper in the layers. But the big question here is, soil multifunctionality is reduced by fire severity. Well, this is a map of the Iberian Peninsula with all the wildfires that occurred in 2021. And the one here is the Navalacruz wildfire, which started in August 2021. It burned more than 23,000 hectares, and it became the fourth most destructive wildfire in the history of the country. So 3 months after this big fire event, we went over to the affected area, and we sampled, dividing our area in 4 different fire severity classes. This being unburned, burned at low severity, burned at high severity with a gentle slope, and burned at high severity with a steep slope, because we wanted to see if there were synergistic effects between fire severity and the erosion associated to slope. So this is our study area in which we can see the sampling sites and the plot display. And we sampled a total of 40 plots, 10 of each severity, and we did a plot characterization in which we measured DVH, canopy cover, and estimations of ground cover. And we also took a series of soil samples in each plot. We took a bulk density sample per plot, and also a topsoil sample, this being from 0 to 5 centimeters, and then a subsoil sample from 5 to 10 centimeters. In these soil samples, we then conducted our analysis. We measure a total of 80 soil samples. Well, in each soil sample, we measured soil function indicators, a total of 23. And we grouped them into 6 different categories or soil functions, which are soil properties, nutrient pools, soil carbon, soil biota, soil activity, and heavy metals. And the data analysis we conducted, well, first, for plot characterization, we did linear mixed effects models in which the random effect was the sample site. And we also did a PCA in order to generate a continuous gradient of fire severity. We, in order to study the effects of fire severity on soil function indicators, we also did these linear mixed models. To test the effects of fire severity on the vertical distribution of soil function indicators, we calculated the differences between topsoil and subsoil values of each soil function indicator, and we conducted linear models again. Last but not least, we studied the soil multifunctionality from an effective multifunctionality approach. This is a combined metric which accounts both for the number of functions performing plus the level of performing of each function. And all this, we did it with R. So, moving forward to the results, for our plot characterizations, we found that the 40 plots that we measured were similar in terms of eastness, DBH, and soil texture, which accounted for comparable pre-fire conditions. Studying the effects of fire severity on soil function indicators, we found different responses. So I'm going to talk about it as a classification I did earlier into the 6 groups. The first are the soil properties, which we found, as you can see over here, in which we have the raw values in the y-axis and the fire severity gradient in the x-axis. We can see that topsoil pH increased with fire severity, and for example, the electric conductivity experimented a punctual increase in the low severity plots. But what I want you to look over here is at this pattern that we can see, which is telling us something about the widening effect of fire. This means that fire is affecting the vertical distribution of soil function indicators, because in the unburned plots, there were no significant differences between topsoil and subsoil values, but with the increasing fire severity, we saw differences. Moving forward to nutrient pools, we can see that there were higher concentrations in the topsoil of burned soils when compared to those of the unburned. For soil total carbon, we have observed a significant decrease in the topsoil. And for soil biota, we found something very similar, significant decreases in the topsoil. But again, I want you to look at the pattern here, in which we can see the opposite effect of fire, which had an homogenizing effect on the differences between topsoil and subsoil values, again affecting the vertical distribution of soil function indicators. For soil activity, we saw a similar drop in the topsoil layer, and for heavy metals, we found significant increases both in the topsoil and the subsoil of our burned soils. So, grouping them of our soil function indicators in order to visualize them better, here you can see the drops in soil biota, soil carbon, and soil activity, as I just told you, and the different responses in soil properties and nutrient pools. However, we can see the clear increase in heavy metal content. So, to sum up, here is the graph of soil multifunctionality, in which we can see a clear decrease with increase in fire severity in the topsoil, but the effects were not significant in the subsoil layer. So, answering the questions I dropped to you before, the first one was, are soil function indicators affected by fire severity, or it was just a matter of burned versus unburned? Well, both of them, because our measured indicators exhibited distinct responses, reflecting both the influence of fire severity and the burned versus unburned contrast. Second question was, did fire affect the vertical distribution of soil function indicators? Well, yes, it did. We observed alterations between topsoil and subsoil values among different fire severities for the same function indicators. On the other hand, the majority of fire-induced impacts were concentrated in the topsoil layer, indicating a higher vulnerability of this horizon. And finally, is soil multifunctionality reduced by fire severity? Well, yes, it was significantly reduced by fire severity in the topsoil. And although a similar pattern was observed in the subsoil, differences among fire severities were not significant in the subsoil. That's it. Thank you very much. And this is my